A ratio can be written 3 ways. And even though they can be written 3 different ways, they are said the way that we say them the exact same way. Okay? A ratio can be written out using numbers and words, 6, 2, 3. It can be written with this dot, dot. Okay? And we say with a colon here, we call it 6, 2, 3. Or it can be written like a fraction, and we still call it 6 to 3. Okay? Can you think of a ratio in real life? A real life example of a ratio?
Yeah.
What? Yeah, Austin.
You have like 10, 25, that's equal to like 10. 8.
Well, I'm thinking, where do you say it was 6 to 3? It was 10 to 1. It was 25 to 2.
Football game.
Ball game, sports, yes. Often your scores are ratio. You have a value to another value. Yes.
You also can do that in recipes where you're making food.
Uh-huh.
And you can where you have 10 to.
You're right. Recipes often sometimes give ratios as well. All right, on with our video.
What are ratios and when are they equal? Think about this question during the lesson. A ratio is a comparison of like or unlike quantities. A ratio can compare a part to a part to a whole, or the whole to a part. How are fractions and ratios similar and different?
Okay. How are fractions and ratios similar? How are they alike? If I go back to this definition,
A ratio is a comparison of like or unlike quantities. A ratio can compare a part to a part to a whole, or the whole to a part.
how is that like a fraction, Hope?
In a fraction, it's the denominator is the whole,
You're right.
and the numerator is the part.
Exactly. A fraction is a part to a whole, part of the whole. And so that's how fractions and ratios are similar. How are they different?
How are fractions and ratios similar and different?
How are they different, Ethan?
I don't know how, but I didn't get it what it meant when you equal that.
Okay, hold on just a second.
A ratio is a comparison of like or unlike quantities. A ratio can compare a part to a part to a whole, or the whole to a part.
Okay, I think as we go on with the video, Ethan, it should become a little more clear. But
I don't understand what it means. Parts of whole to part.
okay, so maybe let's say we had 2 bowls of fruit salad, or even this bowl of fruit salad, and we want to compare strawberries to cantaloupe. That's a part to a part. You're comparing one part of the fruit salad to another part of the fruit salad. It can be a part to the whole. Like maybe we're going to do a ratio of how many strawberries are there in the whole fruit salad. Then you're doing the number of strawberries to the total number of pieces of fruit in the fruit salad. That's a part to a whole, which is also the same thing as a fraction, because a fraction, the definition of a fraction is a part of a whole.
Does that count the strawberries in it?
Yes, yes. Or it can compare the whole thing to a part. And we'll go on and it should make a little more sense, I think. And they're
How
different.
are fractions and
Sorry.
ratios similar and different?
We gave how they're similar. They're different because a ratio can be a part to a part or the whole to the part.
Fractions compare part to whole for like quantities, while ratios can compare part to whole, part to part, and whole to part for like or unlike quantities. How are equal ratios and equivalent fractions related? Both ratios and fractions are equal, equivalent, if they reduce to the same value.
Okay, so just like we've already learned about equal fractions, there can be equal ratios as well. So a ratio of 4 to 6 is equal to the ratio of 2 to 3. Okay, just like 4/6 is equal to 2/3. Even if I write it differently, I know the lights are off, so you may not be able to see this very well in the back, but if I write a ratio of 3 to 10, 3 to 10, an equal ratio could be 6 to 20. It's equal because I took this times 2 and this times 2. Okay?
Still going on.
You're right. I could keep going.
But why did you times it by 2?
I just made it up. It could do it times 3.
Todd is using a recipe to make fruit salad. What is the ratio of cups of cantaloupe to cups of apples?
So 6 cups of cantaloupe and 3 cups of apples. We have to look what they want us to compare. Cantaloupe to apples. That means cantaloupe has to come first because they listed it first. So the ratio will be 6 cups to 3 cups. 6 to 3.
The ratio of cups of cantaloupe to cups of apples is a part-to-part ratio. It can be written 3 ways.
It's a part-to-part ratio because we're comparing one part to another part. And this is how they wrote it. 6 with the word 2, 3, 6 colon 3, or 6 over 3. Yep. But you say 6, 2, 3
So
for
there
all
are
of them.
6 parts cantaloupe to 3 parts apples. Is this ratio in its simplest form?
Yes or no?
No.
No. What would this ratio be in its simplest form? Kirsten? I'm sorry, what? It would not be 3 to 1. It would be what, Owen? 2 to 1. We're dividing 6 and 3 by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. It would be 2 to 1.
No, this ratio is not in simplest form. How do you reduce a ratio? To reduce a ratio, you write it as a fraction and then divide the numerator and the denominator by a common factor. What is the ratio of cups of peaches to cups of fruit in the salad? Let's find out.
Okay, this is a part to whole ratio because they want us to compare the cups of peaches, which is just one part of this salad, to all the cups of fruit in this salad. That means the whole thing.
To solve this problem, you need to calculate the whole. How do you calculate the whole when given the value of each part?
Okay, calculate the whole. We're going to add up all of these. How many cups are in the whole thing? 6 plus 4 is 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 cups total.
To calculate the whole for a ratio, add up the parts. What is the answer? There are 18 cups of fruit in all. So the ratio of cups of peaches to cups of fruit in the salad is a part to whole ratio.
Okay, so they want peaches, and because they listed peaches first, we're going to say the ratio is 3 to 18.
This ratio can be written 3 ways.
There's 3 ways to write it. Is this in simplest form, this ratio?
No.
No, it is not. What would this ratio be in simplest form, Kyla? Not 6 to 1, no. Ellie?
6 to 62.
No. Bella? Yes. Yes, you guys were saying the 6 first. You divide both by 3, you get 1 to 6. It's a 1 to 6 ratio.
The ratio of cups of peaches to cups of fruit in the salad is 3 to 18. What could you reduce this ratio to?
We said 1 to 6.
This ratio reduces to 1/6. If Todd has 2 cups of strawberries, how many cups of cantaloupe should he use?
Okay, if he has 2 cups of strawberries, how many cups of cantaloupe should he use? Well, let's look. We're looking at cantaloupe and strawberries. Right on my screen. We have to do a little bit of work for this one to figure this one out. We want to know about cantaloupe and strawberries. Well, it says if he has 2 cups of strawberries, how many cups of cantaloupe should he use? Question mark here. Well, we are not sure because this doesn't say 2 cups. This says 4 cups. Right now, this says 4 cups of strawberries, use 6 cups of cantaloupe. So if we have 2 cups of strawberries, how many cups of cantaloupe do we need to use? Think about this relationship. We were at 4. How did we get to 2? Ethan?
Subtracted by 2. Or divided by 2.
Divided by 2. So we're going to do the same here. How many cups are needed, Gabe? 3. Good job.
The ratio of cups of strawberries to cups of cantaloupe is a part-to-part ratio. It can be written 3 ways.
Okay, I wrote it as a fraction.
For 2 cups of strawberries, 3 cups of cantaloupe are needed. So Todd should use 3 cups of cantaloupe for 2 cups of strawberries.
Good job.
How many part-to-part ratios can you find from the chart? There are 10 part-to-part combinations in the chart. Now you know what a ratio is, how to write ratios, and how to find equal ratios.
Okay, so you can see this is what they compared to get the 10. They compared cantaloupe to strawberries, cantaloupe to apples, cantaloupe to blueberries, cantaloupe to peaches. Then they went through and compared strawberry to apples, strawberry to blueberries, strawberry to peaches. Then they went through, they compared apples to blueberries, apples to peaches, and then blueberries to peaches. That's how they got 10 different ratios there. All right? All right, guided practice. You should have notebooks open. You should be on page 396. This is understanding ratios. Number 1, look at the set of objects. Write the ratio. That's the first thing we have to do. Then write 2 other ratios that are equal to it. So all together we're going to do 3 things. Write the original ratio, then come up with 2 other equivalent ratios. All right? So, circles to squares. That means I need my number of circles first, then squares. So the number of circles we have, here's 1, 2. So we have 2 circles. I'm going to write it with the word 2. You may write it however you choose. To how many squares? 1, 2, 3, 4. To 4 squares. That's one of my ratios. Now I need to come up with 2 additional ones that are equal. What is a ratio that I can come up with that is equal to 2 to 4? Give me another equivalent ratio. Dylan Allen?
1/2.
1/2. How did you get 1/2?
I divided by 1. 2.
If I divide top and bottom by 2, an equal ratio I get is 1/2. You're correct. 1/2 or 1 to 2. I need one more. Again, my original was 2/4.